Hey YouTube, welcome to my third and final episode on straight line graphs. Today we're going to look at some coordinate geometry, so distances between points. We're going to apply it to a pretty difficult exam question. So let's do this. So the question we got here is saying find the exact length of the line segment joining each pair of points, giving your answers in terms of surds where appropriate. So between 1, 1 and 4, 5. So the first thing I'm going to do is show you how it's looking, and then we're going to look at the short way of doing everything. 1, 1 would be here on an axis. 4, 5 would be about up here. A line segment just joins 2 points. Now to find this length, we're going to form a right angled triangle. We're going to work out how much across do we need to go and how much up do we need to go. Now to go across, we're going from an x coordinate of 1 to 4, which is 3 across, going from 1 to 5 on the y-axis, that's up by 4. So because it's a right angled triangle, to find the length between the two coordinates, we just have to do Pythagoras. So the line segment, I'm just going to call it D, is 3 squared plus 4 squared rooted, which is 5. And you can say units. You don't have to if you don't want to. Now, essentially what we're doing is the exact same thing as the gradient. The only difference is that with the gradient, we would do 4 divided by 3 to work out the gradient. Here we're just doing Pythagoras. So to work out the distance between points, we're going to do the exact same thing that we did before. We're going to take away the coordinates, and instead of doing a division, we're going to do Pythagoras. So I'll show you how it works with part B. So we line up the coordinates. The coordinate that I always put on top is the one that has the most positive numbers. Just makes life a little bit easier. So we're doing 2 take away minus 6. That becomes 2 plus 6, 8. Minus 7 minus 3 becomes minus 7 plus 3, which is minus 4. Then I like to do it here. So we're squaring the components. Then we're adding them. Then we're square rooting them. Saves you a little bit of work from writing another line of work in, doesn't it? So all we need to do now is just type this in the calculator. You're just squaring a negative, right? Root the answer, so we got 4 root 5. So our distance here is 4 root 5, and you can say units because it's a length. Next question, applying it to some exam questions, it says the corners of a triangle are the points P, which is 112, Q minus 3, 4, and R minus 1, 3. Find the length of each side of the triangle PQR, giving your answers in terms of surds. So let's do PQ first. So to work out PQ, we're going to take away the coordinates. I'm going to put 112 on top, minus 3, 4. We're going to subtract them. 1 minus minus 3 is 4. 12 minus 4 is 8. We're then going to square them, add them, root them. I'm going to do it all together at the end. So next thing we have to do is PR. So I'm going to put 112 on top, minus 1, 3 on the bottom. 1 minus minus 1 is 2. 12 minus 3, 9. Square them, add them, root them. Last one we need to do is QR. Now both of them have one negative, so I'm just going to write Q on top then. So QR will be minus 3, 4, and minus 1, 3. Remember, it doesn't matter which one you choose to put on top. Because you're squaring it, it really doesn't make a difference. So minus 3 minus minus 1 becomes minus 3 plus 1, which is minus 2. 4 minus 3 is 1. So we're squaring them, adding them, and then rooting them. Okay, so typing everything in the calculator. Okay, so inputting the lengths, we had 4 root 5. Here we had root 85. The last one we can actually do without the calculator. We have 4 plus 1, 5, so root 5. And these are all your lengths. Part B, hence verify that the triangle contains a right angle. Now to prove that it contains a right angle and we've got 3 lengths, is we just need to apply Pythagoras and show that the two shortest lengths squared sum to the largest length squared. Now the question is, which one's the largest length? You could use the calculator to verify. So what you could do here is root 85 is 9.2 and this is 8.9. So what we need to check is if 4 root 5 squared plus root 5 squared, we need to check if that gives you 85. So with our calculator, let's do that. Oh, there you go. It gives you 85. So you just say equals 85. Now, the next thing you might want to say is therefore, state where the right angle would be. So essentially what's going on is in terms of your triangle, just for visualization's sake, we have the longest length is 85 and the two shorter lengths are 4 root 5 and root 5. Now root 5 was between Q and R. 4 root 5 was between P and Q. So the triangle must look something like this. So the right angle is here. So we can say, therefore, we can say PQR is 90 degrees. PQR is 90 degrees. Just to make sure that we're demonstrating that we know what we're talking about. Then part C is easy. I've actually just done the diagram. So find the area of the triangle. We're saying that the area is a half times the base length root 5 times the height 4 root 5. Root 5 times root 5 is 5. A half of 4 is 2. So you have 10, and you can say units squared for this one. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Final question, a nice exam question. Looking at parallelograms, it says the points P minus 4 minus 1. Now, as I'm reading, you should always add information to your diagram because examiners don't always do it. Q 0, 7, R 8, 8, S 4, 0 are the vertices of a parallelogram as shown in the diagram above. Find the length of PQ. Okay, so this is nice and simple. I'm going to write Q first, so PQ. We're going to say Q is 0, 7, and then P is minus 4, minus 1. Subtract them. 0 minus minus 4 is 4. 7 minus minus 1 is 8. There's no coincidence why you're getting a lot of 4s and 8s. The more questions you do, you'll realize that a lot of the same numbers occur. So here was 4 root 5, just through pure memory. And then let's add it to the diagram. So 4 root 5. Find the coordinates of the point M, the midpoint of PQ. Now, how do we find midpoints? This doesn't require its own video. The easiest way to find midpoints, you add the coordinates and you divide by 2. Midpoint is basically just the average. Yeah, so you add two numbers, divide by 2. So the midpoint of PQ, we're going to write down P and Q. So Q is 0, 7, and P is minus 4, minus 1. Add them. So 0 minus 4 is minus 4. 7 minus 1 is 6. Then we just divide them by 2. So the midpoint M is minus 2, 3. We could just add that. So here in the middle, M is minus 2, 3. Show that MS is perpendicular to PQ. So MS, show that this is perpendicular to PQ. Now here we're not talking about length. So in the last example, we were talking about length, so we used Pythagoras. Now the way to do this one is we want to think about gradients. And we did that in the last episode. So what we want to do is we want to work out what the gradient of PQ is. I'm going to say M and then a subscript of PQ to say that's the gradient of the line PQ. So to find the gradient, we take away the coordinates and do the second number divided by the first number. Now, if you look at part A, we actually took them away already. In the Y column, we had 8. In the X column, we had 4. So it's 8 divided by 4, which is 2. Now, for the gradient of MS, we need to take away the coordinates. So we actually have to do it now. So minus 2, 3, and 4, 0. Take them away. Really, usually I put the 4, 0 on top, but it doesn't make a difference. Minus 2 minus 4 is minus 6. 3 minus 0 is 3. So the gradient of MS is the change in Y3 divided by the change in X. So we get minus a half. Now, what did we state last lesson that always proves when two gradients are perpendicular is you have to multiply them and it equals minus 1. And this is what they're expecting from you in the exam. You can't just say 2 negative reciprocal is minus a half. In A levels, we want to explicitly state that these two multiply to give you minus 1, therefore perpendicular. So you must make sure you say that. Part D. Now find the area of the parallelogram. So they've obviously made us do part C for a reason. How do you work out the area of a parallelogram? Well, it's nice and simple with the information we've been given. To work out the area of a parallelogram, you take the base length of the parallelogram and you multiply it by its perpendicular height. So wherever from one line to the other line, wherever that perpendicular height is, you just do base times height. Now in our case, if you look at our parallelogram, we have PQ. Now I'm going to take PQ as the base length because we have the height of the parallelogram is MS. It's the exact same as the diagram I've just drawn here. It's just rotated. And that's something you have to notice here. And this is where students didn't do so well in this question because they couldn't see that it was just the exact same situation, just rotated. Now we have PQ, right? We have that base length. We now need to work out what the length of MS is, which means we need to take away the coordinates and do Pythagoras. Now we've actually done that. We've done the subtraction. It was minus 6,3, right? So let's just do Pythagoras to those components. And let's see what that gives us. Rooted 3 root 5 equals 3 root 5. Therefore, the area is the base length, which we said was 4 root 5, times by the height, 3 root 5. 4 times 3, 12. Root 5 times root 5 is 5. And that then gives us 60 units squared. And this is our solution. And that's it, guys. So this is coordinate geometry with straight lines. Stay tuned for the next set of episodes where we're going to look at circles. So I look forward to it. If you learned something, guys, please hit the like button. It helps me out a lot, helps the channel grow. And if you want more maths content, make sure you subscribe and turn on the notification bell. So I look forward to seeing you guys in the next episode. Peace.